We continue our introduction to the homogeneous linear system. So in the last example, we saw a system of equations. We look at the augmented matrix, and then we can identify 0, 0 is a trivial solution. Okay, we call it 0. So you can put 0, 0 here. That would obviously satisfy the equations, because right-hand side is all 0. All right, let's look at that. So in such a system, Ax equal to 0 always has at least one solution, which is mainly what? X equal to 0. All right, this 0 solution is usually called a trivial solutions, and any homogeneous equations, Ax equal to 0 has a non-trivial solutions if and only if the equation has at least one free variable. As you can tell, if you have free variable, then you will have infinitely many solutions. Well, let's look at an example right here. Okay. Determine if the following homogeneous system has a non-trivial solution, then describe the solution set. The key is, how do we describe the solution set? Okay. All right. So let's look at, let the A be the matrix of coefficients of the system, and rho reduce the augmented matrix A0 into the echelon form. Looks like this. All right. So sorry, there's a black spot there. I was just filling with the three. That's where it's supposed to be. So you look at the end result. Obviously, x3 is the free variable. Okay. So let's look at it here. So x3 is a free variable. Therefore, we have at least one non-trivial solution, or more than one. I mean, infinitely many. Okay. All right. So continual row reductions into a reduced echelon form, we get this. All right, so the left-hand side translate into the right-hand side. All right, 0, 0 meaning x3 is free, x2 equal to 0, not free, equal to 0, and the x1 in terms of x3. And we write it down this way. Okay, x1 equal to 4/3 x3, x2 equal to 0, x3 is free. So we can write down x1, x3, x3 as something like this. Look to the left-hand side. Okay, so x1 equal to 4/3 x3, x2 equal to 0. Of course, x3 is free variable. Well, now we can just factor out x3. And then we can look at that x3 times the vector. This vector is a scalar vector, 4/3, 0, and 1. Okay, so x3 is factored out, and it shows that every solution of Ax equal to 0, in this case, is a scalar multiple of v. This is your v, right there. Okay, because x3 as a solution set is x3 as a free variable times this vector, 4/3, 0, and 3, and 1. So every solution of Ax equal to 0 is a scalar multiple of this vector right here. Of course, the trivial solution can be obtained if you allow x3 to be 0. Then that's one of the trivial solutions. It's just one of the many solutions. So geometrically speaking, this vector is just a line. Okay, the solution set. So this is the vector we have. This is the vector we have. 4/3, 0, 1. Okay, if you form a vector like there, that's a v right there. Okay, then every solution line on the scalar multiple, meaning lining on this line right there. Okay, so that's our example right here.